Hello everyone, welcome to the third tutorial video for Intel Galileo development board. In the second video, we saw how to blink an LED using Arduino IDE and confirm that our board is functional. In this video, you will see different ways in which we can connect Galileo via a Linux console. Connecting Galileo via Linux console is required to write programs and execute them on Galileo without the use of Arduino IDE. There are several ways to do it. We shall see following 4 of these methods. The first method is to connect Galileo via a Linux console using UART. The second method that we will look into is by connecting Galileo to a personal computer or laptop through an Ethernet cable, configuring a static IP address and then using a shell that is telnet. This method is also known as poor man's telnet. The third method is similar to the second one. The only difference between the two methods is that instead of connecting Galileo to a PC or a laptop, we will now connect Galileo to our local network, assuming that a local network uses DHCP, that is Dynamic Host Configuration Protocol. DHCP is a network protocol that enables a server to automatically assign an IP address to a computer from a defined range of numbers configured for a given network. After this connection, we will use telnet. Fourth and the last method, which is connecting Galileo to Wi-Fi and then SSH, will be covered in detail in the later videos once we are able to boot up Galileo with Linux images having advanced features. The Linux shipped with Galileo in its flash has limited features and does not include drivers for Wi-Fi. Also, to configure Wi-Fi on Galileo, we would need to connect Galileo via a Linux console using any of the above 3 methods. Let us now understand each of these 3 methods in more detail. Let us start with the first method, which is connecting to a serial terminal via UART. UART is Universal Asynchronous Receiver Transmitter. Galileo Gen 1 has 2 UARTs. One of the UARTs is shared with a 3.5 mm jack RS-232 console. The second UART is available on digital ports 1 and 2 on Arduino headers. Since Galileo provides a RS-232 over 3.5 mm jack, we can use a 3.5 mm to RS-232 converter cable as shown in this image. I should call this as a cable 1 for future references. You can make cable 1 by yourself. You will need 3.5 mm stereo 1/8 inch plug, DB9 DE9 female connector, some wires and a soldering iron. The connections to be made is as shown in the image. The Windows system I use for a serial terminal does not have a dedicated RS-232, but it allows serial terminal over USB. Thus, I use a RS-232 to USB converter cable as shown in the image. Let us name this cable Cable 2 for our future references. You can order these cables online from the given links. Please note that a different RS-232 to USB converter cable is required for Mac. Download link for the same is also provided for your reference. We will now connect the 3.5 mm head of cable 1 to the 3.5 mm jack on the Galileo board. Now connect the RS-232 DB9 male end of cable 2 to the RS-232 DB9 female end of cable 1. Now connect the USB end of the cable 2 to the USB port in the system. If you do not have required drivers for the cable 2, please follow the link in the tutorial to download the drivers for your system. When the drivers are installed and required connections are made, you can use Windows Device Manager to check the COM port. The COM port will be available under ports COM and LPT. Note this COM port for later use. For Linux users, you can check the port by typing ll/sys/bus/usb-serial/driver/star/tty* on the shell. A list of all the USB serial drivers with the corresponding TTY USB port will be displayed. Note down this TTY USBX number, which will be required later in the tutorial. Now we can download a serial terminal application for our system. You can download PuTTY for a Windows system from the given link. You can apt-get install putty on your Linux system. For Mac, CoolTerm and Minicom terminals are some of the many options available. Double-click on putty.exe file from the downloaded folder. A new window will open. We will now configure putty to open a serial terminal. To configure putty, we will first select the serial option available under the sessions category. Once we have selected the serial option, the same window will now display two options at the top. One of them is the serial line option, where we will enter the COMX, which we had seen earlier in the device manager. For Linux systems, type /dev/tty/usbx under the serial line option. We will now set the baud rate that is supported by the Intel Galileo board. To set the baud rate, we will type 115200 under the speed section beside the serial line option. You can save these settings for the later use by typing a name in the Saved Sessions options and selecting the Save button available to its right. We will then click on Open button, which is available on the right bottom of the window. A new blank window will open up. We can now power on Galileo and you can see the boot up on the console. Note that for a Galileo board, following two methods will work only if the Linux kernel images have uclipc support. This is because images providing uclipc support is required to download Arduino sketches to Galileo. The other flavor of glibc, which is the eglibc in Galileo Linux images, does not activate the USB client driver on Galileo, and thus we cannot download sketches on the board using Arduino. The Linux image which is available in the flash contains uclipc packages, and thus we are able to download sketches and execute programs using Arduino. The second method is basically to provide a static IP address to Galileo, which will be required to log in to Galileo using Telnet. We will first connect one end of the Ethernet cable to the Ethernet port of Galileo and the other end of the Ethernet cable to the Ethernet port of the system. Next, we will connect one end of the USB cable to the Galileo's USB client port and the other end to the USB port of the system. We will open Arduino IDE and do the configurations for the board and serial port selections. To check for the configurations and USB cable connections, refer second video tutorial. We will now write an Arduino code to assign a static IP address to the Galileo board. We have two functions in any Arduino sketch. One of them is a setup function where we write the initial conditions in our program, and the other is a loop function where we write anything that needs to be continuously executed. We will use system calls to issue a command to Galileo's operating system from an Arduino sketch. First command in the setup function is a system telnet-l/bin/sh. In order to configure the Ethernet network interface, we will first have to call telnetd, which is an application protocol which will provide a bidirectional interactive text-oriented communication facility. Here, -l/bin/sh is to force clients to use line-at-a-time mode. Next, an ifconfig command to activate Ethernet interface given by eth0. We will set the IP address in our network and also configure the net mask using this command through system call. Once this interface is activated, we will echo the IP address to check if the configurations is correct. So, in the void loop, we will type system ifconfig eth0 and redirect the output to /dev/tty/gs0 in order to view the output from the Galileo's operating system in the Arduino serial monitor screen. Let us provide a little delay using sleep 10 so that we can properly view the output on the serial monitor window. Next, we will compile and verify the code by clicking the tick mark button on the top left of the Arduino window. If the sketch is compiled successfully, We'll upload the sketch by clicking the rightward arrow button available next to the Verify button available in the top left corner of the window. Once the sketch is successfully uploaded to the board, we can open Arduino Serial Monitor. Arduino Serial Monitor can be opened by clicking Serial Monitor under the Tools tab. A new window will pop up and we can see that a static IP address has been assigned to Galileo. Now we can telnet to Galileo using this IP address. Next, we will open PuTTY and select the telnet option under the session category. After selecting telnet, the hostname field will be available in the top center area of the window. We will now enter the IP address in this field that we initially assigned to the Galileo using Arduino Sketch. Make sure the port field next to the hostname field displays number 23. You can save these settings by giving it a name in a similar way as discussed earlier. After we click Open on the bottom right corner of the window, a new window will pop up. The third method is very similar to the second method. Only difference is that instead of providing a static address, we would program Galileo to acquire a dynamic IP address from local network. We will connect one end of the Ethernet cable to the Ethernet port of the Galileo and the other end to any of the output ports of the network router. Then we will connect the USB cable between Galileo's USB client port and the USB port of the system. We will open Arduino IDE and do the configurations for the board and serial port selections. We will now write an Arduino code to assign a dynamic IP address to the Galileo board. As discussed earlier in the tutorial, we will issue a telnet command to initialize network interface. Once the application is started on Galileo's OS, the IP address is assigned dynamically by the DHCP in the router, and we just need to echo the IP address from the Galileo's operating system and view it on Arduino Serial Monitor window. So we will issue a system command ifconfig eth0 and redirect the output to /dev/ttygs0. We will also provide a delay with sleep 10. Next, we will compile and verify the code by clicking the tick mark button on the top left of the Arduino window. If the sketch is compiled successfully, we upload the sketch by clicking the rightward arrow button available next to the Verify button available in the top left corner of the window. Once the sketch is successfully uploaded to the board, we can open Arduino Serial Monitor. Arduino Serial Monitor can be opened by clicking Serial Monitor under the Tools tab. A new window will now pop up and we can see that an IP address has been assigned to Galileo. Now we can telnet to Galileo using this IP address, and we see a new window will pop up. Thank you for watching the video. I hope you enjoyed it.